Every single image on your screen, whether it's an epic world in a video game or, hey, even this explainer right here, it all starts out as simple math. But how in the world do we get from a bunch of numbers to visuals that look totally real? Well, that's the magic we're going to dive into today.
It kind of seems impossible, right? How can a list of abstract numbers create these beautiful, complex worlds that we can just jump into and explore in real time? That's the big question we're going to tackle.
So here's our game plan. We're going to start with the hardware that makes all this possible, the GPU. Then we'll get into the basic building blocks of, well, everything you see. After that, we'll walk through the digital factory that puts the image together. And finally, we'll tie it all back to what we really care about, getting that buttery smooth performance in our games and videos. All right, let's kick things off with the absolute powerhouse behind the scenes, the graphics processing unit, or as we all know it, the GPU. This thing is the specialized engine that makes all modern visuals happen. A GPU is a total specialist. Its one and only job is to take a whole bunch of data and turn it into the images we see on screen, and to do it at mind-blowing speeds. But how it gets that speed is what makes it so different from a computer's main brain, the CPU. This slide has the perfect analogy. A CPU is like one genius craftsman. It tackles really complex problems, but it does them one at a time. A GPU, on the other hand, is like a massive army of thousands of workers. Each worker does a simple, repetitive job, but they all do it at the same time. That's called parallel processing, and it's the GPU's superpower. I mean, think about it. A 4K screen has over 8 million pixels. A CPU would have to figure out each one by one. The GPU's army can handle huge chunks of them all at once. It's no contest. Okay. So we've got this army of processors, but what are they actually building with? What are the raw materials? To get that, we need to understand the basic language of computer graphics. Before a GPU can render a single pixel of a lifelike character or a crazy explosion, it has to start with the ingredients. And for a GPU, those ingredients are just math, plain and simple. This is basically how a computer sees the world. It doesn't understand a character standing in the corner or a bright red sports car. Nope, it understands a set of X, Y, and Z coordinates that say where the character is, and it gets a set of numbers for red, green, and blue that tell it what color to make the car. Everything gets boiled down to pure data. So if the computer is just playing a giant game of connect the dots with all these coordinates, how does it go from a list of points in space to a complex 3D model? What is the one fundamental shape it uses to build literally everything we see on screen? And the answer is the humble triangle. And not just a few, we are talking millions. Every amazing curve on a character model, every detailed surface in a game environment. It's all just a web of simple little triangles. They're the atoms of the 3D universe. I love this Lego analogy. It's just perfect, right? You can build anything you can imagine, a spaceship, a castle, anything, if you have enough basic bricks. For a GPU, triangles are those Lego bricks. Okay, so we have our building blocks, millions and millions of triangles. Now let's see how the GPU's digital factory puts them all together into a finished, polished image. This whole process is called the graphics pipeline, and it's basically a super fast assembly line. First up, vertex processing figures out where the corners of all our triangles are supposed to go in the 3D world. Next, rasterization takes that 3D blueprint and basically squishes it down onto the flat 2D grid of pixels that is your monitor. And then, the final step, fragment shading. That's where the image really comes alive. This is where every single one of those pixels gets its color, lighting, and texture. Man, this final step is where the real magic happens. This is what makes an image look real. The GPU's cores are frantically calculating how light should bounce off a surface to create believable shadows and shiny reflections. It's how a flat polygon wall suddenly gets a rough, detailed brick texture. This stage is what turns a basic 3D model into a breathtaking, immersive world. So now we know how one single static picture gets made. But in games and videos, we don't care about one picture. We need motion, and that motion needs to be absolutely seamless. Get this. That whole complicated assembly line we just walked through, all of that work produces just one image, a single frame. The real challenge, the true miracle of the GPU, is that it has to run that entire process from start to finish dozens of times every single second. And 60 is kind of the magic number. To trick our brains into seeing smooth, fluid motion that feels real, a GPU needs to draw at least 60 of these detailed pictures every second. Anything less, and things start to feel jerky and unresponsive.
And this brings us to what might be the single most important metric for performance, frames per second, or FPS. It's a direct measurement of how much work your GPU can get done. The higher the FPS, the smoother your game looks, the more responsive it feels, and the less you want to pull your hair out when editing video. And this is exactly why we're all obsessed with FPS. In a competitive game, a high frame rate means the world updates instantly with your mouse movements. It's the difference between landing a headshot and getting taken out. And for video editors, it means being able to scrub through a high-resolution timeline with tons of effects without the whole thing grinding to a halt. It's just crucial. To try and put this into perspective, just think about this. A modern GPU isn't just drawing 60 simple pictures a second. It's creating 60 incredibly complex paintings per second, each with its own lighting and shadows and textures calculated from scratch. The amount of raw calculation is just staggering.
And there you have it. That's the journey. From a simple list of numbers, through a digital assembly line building with triangles, all the way to a rapid-fire stream of images that our brains see as a living, breathing world. That's the incredible power of the GPU. It really makes you wonder, doesn't it? As this tech gets faster and faster, able to handle way more triangles and even more complex lighting, what new levels of realism are we about to unlock? What are the virtual worlds of tomorrow even going to look like? It's a pretty exciting thing to think about.